Hi, my name is Rogelio Nochebuena. I'm a student at Duke University. My professor is Dr. John Reich Schneider, and this is the last portion of our class associated with managing machine learning projects. And our final project, in my particular case, is figuring out ways to shield projects associated with energy storage at utility level from ethical and privacy issues. The solution that I like to explore is a supervised machine learning system with label information as well as test data, and comes as a result of the fact that there is a substantial reduction in the price of solar photovoltaics, wind equipment, and materials, and those make the energy storage more affordable, and as such, the utilities can generate a higher profit by using this tool while extending the life expectancy of the batteries. We perform a basic task analysis, and we follow in all the steps associated with CRISP DM process. This is the slide that shows the basic underpinnings of supervised machine learning tool, and as I say, it's a label data, and the labels could be energy generated, power consumed, and so on and so forth, ancillary services, which are sources of revenue that the utilities can get in addition to selling energy. And then the labels, we can put the sell price. If we're buying the energy from prosumers, prosumers are consumers that have surplus energy that we can buy from, as well as to use the blockchain to make economical transactions. The basic model, the basic machine learning model could be things like multiple regressions, neural networks, and other schemes that can give us predictions related to a number of things. In this particular case, could be the price of the energy that we sell, and it could be also sold in different markets, such as the spot market or the merchant market. Um, as I mentioned, the user supply us with some information, and they are listed over there. The user has the capability to introduce weather-related information, and that helps them to figure out how much energy they can produce or store. They also have flexibility to introduce different tariffs to satisfy the demands of all the segments of their market. Um, the machine learning tool produce information related to pricing, how much energy is available to sell, and what conditions the batteries are operating, and so on and so forth. They mentioned earlier, but in the label section we include things if we're buying energy from the blockchains or prosumers or other forms. But that same information could be uh, introduced as an output. So in other words, we can sell in different markets as well. Some of that information is confidential, but from the point of view of utilities, but if that information can be looked at the State Utility Commission, because in the U.S. most of the utilities are entered in a regulated market. The bulk of the information in our model is available to the users, with the exception of the actual algorithm used, but most of the items required for them to run the tool are available, and therefore we can say that we are transparent. In some instances, there is things related with uncertainty because, for instance, um, renewable energy is fluctuates, and to reduce the impact that the user could have, we provide them with certain levels of confidence related or prediction. So having that information, the client is more capable to make the correct decisions. Okay, well, while privacy is something that we address, is not our main concern because we rely on that the utilities have already sanitized the information. But also we focus on what is called differential privacy security that tell us that the calculations of the modeling that we are utilizing or the approach that we are utilizing, from that information we cannot tell whether it comes from individual data or was bunched as an input database. That allows to utilize information as an aggregate, and also we maintain privacy of the users. Potential source of bias are listed over there, and we are going to address them in more detail in a second. The first one is data collection. While collecting the data, there could be biases around those because there is a time discrepancy between when we collect the data and when it is used. There is also the representation bias because different groups or entities consume energy in different ways, and one of them is, for instance, more affluent neighborhoods are going to be consuming by far higher energy per capita than poorer or rural areas. The other source of bias could come from while we're defining the features and the labels, and some of them could be the measured bias. In many instances, we're going to utilize proxy information, and that leads us to simplification, and therefore there is no the granularity that we would like to have to make our predictions more accurate. Another is how we measure the information or how accurate we try to collect it, and that can also vary among different groups. And the other area is the training and evaluation stage, because when we are learning how to utilize the model, at times our choices amplify the disparities among different groups. The cost function may also uh, have an impact in the performance. In some instances, it comes at the expense of the consistency with which we are gathering information among different groups. During the deployment of the tool, there are also areas in which we can find mismatch, um, because the way in which the tool was intended may not be exactly how the user is utilizing it. And at times it comes because when the developers are making the algorithm or the tool, they are not taking into consideration the overall environment that surrounds them. The last source of bias comes from the feedback loop. And here the design incorporates feedback loop, which influence the training of data and thus also modify the outputs. However, there are ways to mitigate the bias in systems. The first one, well, we want to emphasize the fact that we're going to be putting a lot of attention on three basic elements, which are fairness, accountability, and transparency. Um, One of the things that we need to do is to create an auditing plan for fairness and start with how we collect the training data, then how the test set is formed, and also what is the performance of the test set, and finally how do we monitor the production of, let's say, energy or other things. One of the things that we need to emphasize also is that the artificial intelligence tools help us to simplify the process of evaluating fairness across the whole board. However, it requires that we have access to demographic data. Well, with respect to the feedback loops, some of the risks they take time to materialize, and in that process, things like environmental conditions may change or vary the tariffs or things of that nature, and we need to take it into account. So there are ways to evaluate the feedback loops. Uh, One of them is to invite for us to invite the customer to provide us their insight, their ability, and other information. Also to identify ethical risks on regular basis, review them, and mitigate them, eliminate it, or whatever. And also, we're accountable for executing the feedback that the customers provide, and follow up with the risk analysis. In conclusions, we can say that we presented um, ways to address how the the use of energy storage at utility scale can improve the Opex and financial as well as environmental conditions for utilities. But also we need to shield them from ethical and privacy issues. We found that there are diverse sources of bias and how they could modify or affect the project overall. Also, there are several mechanisms that we try to implement to reduce the impact of the bias and bring fairness, accountability, and transparency to our work. And then, with respect to the laws associated with consumer privacy, it's not our main responsibility, but we allow the utilities to deal with that issue. However, we anticipate that they have sanitized the information that they provide us with, and uh, definitely is our responsibility to deal with private information in an ethical and correct fashion. Thank you very much for your attention.